Alright, 9.7 is about vectors. Now the nice thing about this chapter, or this section, is we have actually done almost everything in here. We're just using it in a different way now. When we're given a vector, and I know this was on your assignment, on your last assignment, okay, component form looks like this, correct? Okay, so it would have numbers maybe at 6, -2. That would mean that my vector, from its initial point, went 6 units, which way? Right. And down 2 units. And then this would be my, anybody remember the name of that one? What's the name of the ending point of a vector? Starts with a T. Terminal point. Okay, so just a little short review there of what a vector looks like, how you would describe it. Okay, 6, -2. Maybe it is vector AB. Okay, just a quick refresher there. Now the first thing that's actually in the book is the magnitude of a vector. The magnitude of a vector is the distance from the initial point to the terminal point. Okay. Out of that sentence, what is a word that you feel was probably very important? Distance. Good. Distance. That's very important to us. Because the magnitude of a vector is just the distance from the starting point to the ending point, right? So if I gave you P and told you it was the initial point, and I gave you Q and told you it was the terminal point, what do you suppose you're going to have to do? You're going to have to do the distance formula. You're going to have to find the distance. Now remember, if they give you a graph, okay, and I've had this already today, if they give you a graph of a vector, I've had people tell me, well, I can count the distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. You can't do that diagonally, right? You can't count like that diagonally. It just doesn't work. Okay? You are going to have to find the distance using distance formula. Okay? So, that takes us to the question, what is distance formula? Anybody remember?
Is it in the square root?
It is in the square root. You fill the inside out, McKenna? X2. And that equals my distance, right? Okay, so make sure you know that formula. Okay, that should be one that we should have close to memorized by now. We've used it so much. Now, we haven't talked about this to this point. Okay, but I want you guys to pause in your notes for a second so we can talk about this. That distance formula, let me draw my vector first. 3, 6 would be somewhere up here, right? And 2, -7 is going to be somewhere down here. Everybody agree with that? Okay. Your directions are going to tell you that it's vector PQ. So that tells me it starts at P, ends at Q. Okay, your directions will say that in your book. This distance formula is actually just Pythagorean theorem. Okay, so let's think about this. If I have a square root over this whole side, what's the opposite of square rooting? Squaring. So if I squared this side, my square root would cancel, right? But what I do to the right side, I got to do to the left side. So I would have d squared equals x2 minus x1 squared plus y2 minus y1 squared. Everybody agree with that so far? When I subtract two numbers, a bigger number from a smaller number, aren't I finding how far it is? Like on your elevation problem on your last assignment, you subtracted your big elevation of 14,000 feet minus like 5,000 feet, and that gave you how much your elevation changed, right? Okay, so I'm finding the distance or how much it changes. So if I take x2 minus x1, isn't that just how far left and right I travel? Okay, so that would just be my x, right? Yeah? Okay, equals d squared plus, this would just give me my up and down distance. So that'd just be like y squared. And then this would be, not d squared, that'd be my side d, right? Because that would be the distance of my vector. Isn't this just Pythagorean theorem? A squared plus b squared equals c squared, because my right angle would be right there, correct? Straight left and right, straight up and down. Okay, so it's the same thing. It's just got a few different letters in it, but it's really just the Pythagorean theorem. You have your leg squared equals your hypotenuse squared. So when you do this, do you suppose we're going to want decimal or radical answers? Radical. We stick with radical out of Pythagorean theorem, right? So when you do, can I erase this? We good here? When you do distance formula, you want radical answers. Okay, Royal, do you have a question? You sure? I can go back. I can go back on what I had up there.
Yeah, I was just wondering how you got to that one thing.
To this?
Yeah.
Because x2 minus x1 is just going to give me how far I moved on my x-axis. y2 minus y1 is going to give me how far I moved on my y-axis. So like if I started here, x2 minus x1 is going to give me the distance there. And then y2 minus y1 is going to give me the distance here. Does that make sense? Okay. All right, so let's go ahead and let's find the magnitude of this vector. So x2 is, does it matter if it's 3 or 2? No, it doesn't. Okay, so we have square root, Seth said 3, so it'd be 3 minus 2 squared plus 6 minus -7, right? Which would give you plus, bless you. 3 minus 2 is squared, 1. 6 plus 7 is, squared, 169. So I actually have the square root of 170. It doesn't sound like a number that's probably reducible, but we should check. I can't think of anything that would go into it. Didn't find anything? Okay. I don't think there is. So it'd be the square root of 170 units, right? Because if I'm finding a distance, I do need a label on that. Because it's a distance. It's how far are you going. Okay. So if they ask you to find magnitude, you want to use what? Distance formula. Okay. They have 3 examples there that they worked through. I'm not going to do that. Okay. I'm just going to, I know you guys have used the distance formula a lot. Okay, I think we should be able to use that to come up with our answers. Okay, the next thing, and probably the most confusing part of the lesson, is direction of a vector. Okay, your direction is determined by the angle it makes with a horizontal line. What words seem to be important in that one? Angle. So your direction is going to be an angle, right? Okay. And horizontal line. Okay, those are your important words out of that sentence. It's an angle based on a horizontal line. Okay. So, looking at example 2, they give you a graph. It goes by 5s. Your initial point is at 5, 5. Your terminal point is at 25, 20. And basically what they tell you is this is a ship. Okay, and that's the most common time that you're going to use direction of a vector is with navigation. Okay, it's going to be like with ships, with planes, things like that. Okay, so we have to figure out a few things, or a couple things actually. First of all, they tell us that the x and y axis are in the label of miles per hour. Okay, so what that means is if I find magnitude, I actually find speed here. Because both of these are in miles per hour. When I found magnitude up here, it was in units, right? Because that was, both of these labels were in units. Now it's in miles per hour, so if I found the magnitude, the label would be miles per hour. Okay, so part A actually tells you to find the speed of the ship. Okay, what they're asking for there is just the magnitude. What's the magnitude? Because your label is going to be in miles per hour, which we know is a speed label. So when I do that, I have the square root of what? 25 minus 5, which is? So I have 20 squared plus 20 minus 5, which is 15 squared. 20 squared is? It's 400. Plus 15 squared is 225. So I have the square root of 625, which is 25. Okay, again, I think you guys could do that. Some of you might take a little bit more time than what we did. Okay, but we should all be able to come up with that out of distance formula. My label is miles per hour. And that's only because they told us that my axis, or my axes, were in miles per hour, right? Hey, if they'd have told me kilometers per second, bless you, my label would be in kilometers per second. They told me they were in feet, it'd be in feet. Okay? So there I found my speed. Okay, I think we could have done that as long as we knew the terminology. Now the second part is the new stuff. They want us to find the direction the ship is traveling relative to east. Okay. Now, wouldn't east be a horizontal line? Okay. So that kind of brings you back up to here in that definition. Hey, we want it. It's referenced by the angle that it makes with a horizontal line. Okay. No. When you're looking at a map, north is up, down is south, right is east, left is west. No. Your north is always up, down is always south, right is always east, left is always west. Always. Any map you can pull up, that's how it's going to be. If I just took a map of Nebraska, I'm not going to throw it up here and have the panhandle over here and have the state drawn like this, am I?
Probably not.
No, because that would put south up, right? You guys like my beautiful Nebraska? Okay? You would have it drawn like, it looks worse when I flip it over like that. You'd have it drawn like that though, right?
Yeah.
Because north is up, down is south, right is east, left is west. That's just how we always draw it with maps. So everybody's always on the same page.
So no matter what.
No matter what, north is up. Always. Okay? So we have to find, now we know we're finding a what? Angle. Okay, I'm finding an angle and my horizontal line is east and west, right? We are looking at this line. Okay? Because if I was going this way, I would be going directly east, right? If I was going this way, I'd be going directly west. Now obviously I'm angled this way, so I'm going some east and I'm going some north. Okay? Now, got to be careful there though. Okay, that's what we all want to say. We all want to say northeast. Okay, I'll show you here in a second why it's not northeast though. Okay? Now, if I'm finding my angle based on my horizontal line east, does everybody agree, or can we all agree that I want to find that angle measure? Okay. So I'm looking for this angle measure right here. Okay. We've, in the past, the last few lessons, we've found a lot of angle measures. You guys agree with that?
Yeah.
Using what?
Your different things.
My trig functions. Okay, I have to use my trig functions. So, I need to take, and I need to figure out what I know. Well, do I know the height? I do, because it started at 5 and it went to 20, right? So my height is 15. Do I know my base? Started at 5, went to 25. It must be 20. Okay. Which trig function, Royal, can I use to find that angle?
Tangent?
Tangent. Because this angle, from this angle, I know the opposite and I know the adjacent, correct? Okay, so I do tangent of x equals 15 over 20. But Seth, since I am finding an angle measure, I must use the inverse. So I have x actually equals the inverse tangent of 15 over 20. And then what do I get for an angle? Somebody who's doing that on their calculator.
36.9.
And it's an angle, so it's degrees, right? Okay. A lot of us could have got to that point. This is where I told you it's not northeast. Okay? Because I'm basing my direction off of this angle. Okay? Well, wouldn't this, if this angle was 36.9 degrees, wouldn't that also be northeast right here? Yeah, it would be, right? So there's actually two different vectors that could be going 36.9 degrees northeast. Okay? We want to say that I'm going 36.9 degrees north of east. Because instead of going directly east, I'm going 36.9 degrees north of that, right? Okay, so you just have to be careful. I know that's something that you've never said before. Okay, but I'm going 36.9 degrees north of directly east. Okay, so that tells me that on this plane, instead of going this direction 36.9 degrees, I'm not doing that, am I?
So would that be east of north?
That would be east of north. You're not really ever going to say that, though. You're always going to be in terms of west and east. Okay? We don't want that one. We want this one over here. Like, that'd be a big difference, right? If you were trying to if they were trying to communicate with a ship what direction to go, this one would end in the Arctic. This one would end in Japan. Right? There'd be a big difference. You guys agree with that? Big difference, yeah.
Would 45 be northeast? 45 degrees?
No, you're still going to use your reference of this. You'll never just say northeast. Okay? So this vector, let me get this down here. This direction would be north of east. This one would be north of west. This would be south of west. This would be south of east. Okay, so your last words should always either be east or west. Okay, so you would be finding the angles that touch your x and y axis, basically, right? Or your east and west. You would be finding these four angles. Will you ever find these four angles? No. Always find the ones that are touching your horizontal line. Just like our definition said, it's determined by the angle it makes with a horizontal line. Okay, so you always find the angle referencing to the horizontal line. Yes. For real, they really do. Yep. Not even making this one up for you guys, Royal. Hey, this is the real deal. Okay. Alright. I don't have a ton left for you. Let's just go through a few quick things. If two things are equal, what does that mean? They're the same, basically, right? Okay, so if two vectors are equal, does their magnitude have to be the same? Yes. Do they have to be going the same direction? Yes. Okay, that'd be the only catch. Equal vectors have the same magnitude and they're going the same direction. Okay, so if I have two vectors, they're both 8. With us, Travis? Two vectors, they're both 8. One's going north of east, one's going south of east. Are they equal? No. Okay, keep that in mind. The other thing, and the final thing I would have for you, is that if you have two vectors, and they tell you to add those vectors together, literally just add them together. So vector EF, my new vector would be -3, 10. Add your x's together, add your y's together. Okay, they will give you a new vector. Can we do that part? That's not bad, right? Okay. How do you tell if two things are parallel to each other?
Same slope.
They have the same slope. Keep that in the back of your mind. Keep that in the back of your mind. Slope formula, right? Okay, just keep that in the back of your mind. We've done a lot of that. Okay, so there's going to be a little bit of that on your assignment possibly. Okay, you should know how to find if two things are parallel to each other. Okay, and like you guys said, you just use slope formula. Okay, I know I rushed through the end of that. I wanted to get to this lesson so you guys could do this with some time. You don't have a ton of problems, and most of them aren't super difficult. If you have questions, let me know. You will need one full sheet of graph paper. It's just going to want you to sketch a few vectors. It's not going to be anything too difficult, but you are going to want one sheet of graph paper.